All right, you guys, I'm going to work out the review. I'm going to try to go as quickly as I can here, but all right, for number one, is it is a vertical asymptote. So I would say plug in when you get a 0 on the bottom and not on the top. It is a vertical asymptote all of the time. Okay, so for vertical asymptote, we're going to get positive or negative infinity. So you want to just make sure that you check either side. Okay, so if you were to plug in 1, you get 0. So it'd be 1 over 0. So that means it's a vertical asymptote. So I'm going to test 1. This is saying test to the right of 1. The answer is positive or negative infinity or d/any. For every vertical asymptote, it's always going to either go like this, like this, like that, like that. Okay, so we're looking at positive or negative infinity. So if I look to the right of 1, so pick 1.1. If I plug 1.1 into the top, I get a positive number. 1.1 into the bottom, I get a positive number. Positive divided by positive is going to be positive, which makes it positive infinity. It's going to go up like that. So that would be my answer for number 1. For number 2, I'm just going to go ahead and factor it because I'm not really sure what's happening here. There might be a vertical asymptote, but I'm not sure. So I would say let's just factor it. So you've got the limit as x goes to 1. So I've got x plus 2, x minus 1. On the bottom, we have x minus 1, x minus 3. So we have a whole. We remove that. So this is just a normal question. So I'm just going to plug into the top and plug into the bottom. Okay, if this was going to 3, there is a vertical asymptote at 3, but I'm not asking you for the limit at 3. I'm asking you for the limit at 1. So I don't care what's happening at 3. So here we would just plug in. So you would get 1 plus 2 on top, 1 minus 3 on the bottom. All right, for number 3, I'm just going to go ahead and plug in. When you plug in, you get 0 over 0. Yeah, 0 over 0 means there's probably going to be a limit. This is not a vertical asymptote. A vertical asymptote is only when you have something over 0. So this is just factor it. Is it a trig? Whatever. I need to simplify it, so I'm going to take out a 3x on the bottom. So when you take a 3x out, so we get sine of 3x over 3x, and then you get x plus 3. Remember, this is from the earlier sections, but this, as x goes to 0, this goes to 1. So now I have 1 over x plus 3, and now I could drop in the 0, and we get 1 over 3. For number 4, plug in, you get 0 over 0. That means you can factor. You really should know how to factor a cube. I think when we taught this in Algebra 2 honors, we used u and v. I like to just think of it as find the cube. So it's going to be x minus 3. So whatever this sign is what the sign of the first parentheses becomes. Then what I do is I square this, I multiply them, and I square it. That's how I remember the formula. So I square the first one, I times them, and then I square it like that. There's always only one minus, so since this is minus, this has to be plus, and then I have x minus 3 here, which means there's a whole, but which means there's a limit, right? If I crossed out, I have a hole on my graph, I'm going to plug in. 3 squared is 9. 9 plus 9 plus 9 is equal to 27. All right, so number 5 is learn to recognize this. Nothing's canceling out, and when I plug in the negative 1, I get 0 on the bottom. I don't get 0 on the top, that's a vertical asymptote. So I'm just testing. Is there's a vertical asymptote at negative 1? So I'm going to test at x equals minus 1. This is saying from the left-hand side, so I need something smaller than negative 1. So I would just do negative 1.1. Because you don't have to get values. That's what some of you are doing. You're wasting time. If I do negative 1.1, if I plug into this, it's negative, negative, which makes the top positive. Bottom becomes negative. So in this case, it's going to go to negative infinity. So what you have to accept is the second that you recognize as that vertical asymptote, it's either going to positive or negative infinity. So this one's going to negative infinity. All right, for number 6, now we're talking about x goes to infinity. is these are growth rate type problems, okay? So for me, is there's only two really types of questions we deal with when we're going towards infinity. As x goes to infinity, we're talking about a horizontal asymptote, okay? So if it's just a normal, you know, x plus 1 over x squared minus 2, bigger on the bottom, goes to 0. If it's the same, 2x, 3x plus 1, it's 2/3. If we do the limit as x goes to infinity, limit as x goes to infinity. So these are rational functions. We're looking at our powers. This isn't quite a rational function. When you rewrite this, limit as x goes to infinity, x squared over 2 to the x, is this will be crystal clear. They are growth rates. The slowest one is square root, or a log. The middle one is x squared, and then the end one is exponential. Okay, so exponential is by far the strongest for what we deal with. So the bottom's, it's bottom heavy, you can think of it like that. So then this would go to 0 for number 6. Number 7, this is just bigger on the bottom, so it's going to go to 0 for number 7. Number 8 is this cosine of x, or cosine I should say, cosine. So plug in. This is weird. We need to know that 1 over infinity goes to 0. So really when I drop it in here, it's 5 times the cosine of 0. Is evaluate the cosine of 0. Cosine of 0 is 1. 5 times 1 is 5. Okay? So you still want to plug in. That's different than this. Cosine of x going to infinity. You plug it in, you get cosine of infinity. That is different. We cannot evaluate the cosine at infinity, right? Because it's going up and down and up and down. It oscillates. So this does not exist. But this is different because we're plugging into this, which gives us 0. Cosine of 0 does have a value. This is why number 9 would be DNE. And again, sine and cosine, I'm going to draw the sine curve here for a second, is the sine curve. If I asked you to evaluate it at infinity, we can't do it. It's not tending towards a value. It is oscillating up and down. So we just say that that does not exist when the cosine is on top like that, when there's nothing on the bottom, okay? For this one, I'm feeling a vertical asymptote. Is you have to, my eyes go right to this, right to the bottom. I get 0 on the bottom. So it's going to be negative 9 over 0. Not that you need to do that, but you need to know that this is a vertical asymptote. There's nothing we can do to get rid of the 0 from the bottom. So we accept it. It's a vertical asymptote. So at 3. So I would just do the little chart here. So x equals 3. That means here you have to test both sides. I'd be careful with this one just because you got a lot going on here with the square. Most of the time when it's to the whole number, not right or left, it is DNE, but it's not always. This would be one I would be cautious about. So you want to check both sides. So I'm going to pick something smaller than 3. So just 2.9. So watch, negative x squared. It's so helpful if you can factor it. Because now when you plug in, let's say 2.9, I'm just looking at that and I just know that it's negative. So if this is negative, I get a negative on the bottom, the top stays negative, it becomes positive. So there it's going to positive infinity. And then for number 10, from the right-hand side would be 3.1. When I plug in 3.1, I'm going to get a negative on the top. I'm going to get a positive on the bottom, which goes to there, which makes this one D and E. Okay? All right, number 11. So this is, it always gets a little weird with exponential to negative infinity. So whether it's 3 to the negative x going to positive infinity or 3 to the x going to negative infinity, I would say just plug it in. So let me do these off to the side. Is if you did the limit as x goes to infinity of 3 to the negative x, just plug in and see what happens. If you just plug in here, you're going to get 3 to negative infinity, which is 1 over 3 to the infinity, which is 0. So this goes to 0, this goes to 0. Now I have the limit as x goes to infinity of 2x over 3x. Remember, when the powers are the same, we take the coefficient, and it looks like that, okay? All right, number 12. There's a lot going on. I would do them as 2 separate questions. The limit as x goes to infinity of sine of 1 over x. So if I plug in sine of 1 over infinity, is I'm just evaluating inside the parentheses, which is 0. So the sine of 0 is 0. So this goes to 0. The one on the right-hand side is just a normal rational function. Limit as x goes to infinity. So it's same power. So 6x squared over 3x squared. You take the coefficient, it's 2. So 0 minus 2 is equal to negative 2. All right, for number 13, you're looking at the coefficient. I mean, you could if you wanted to. The negative infinity might throw you off a little bit, but I mean, basically you're doing the coefficient because the powers are the same. If you're not sold on it, you could say it's 3, think of negative infinity squared, 1 negative infinity squared. The negative infinity squared comes out as positive, so we're not really worried about a negative here. So it really just works out to be 3, which is the coefficient. For number 14, this is pretty simplified. This is what you have to see. You get the 0 on the bottom, it's an asymptote. So I'm just going to go ahead and test. Is when you have an asymptote, I'm going to keep saying it, but when you have an asymptote, it is positive or negative infinity or DNE, okay, depending if they're going in opposite directions. So I think the key was wrong on this. I probably forgot to put a minus or a plus above the 2, but we'll do it as it is right now. So you want to test both sides. So if I test negative 2.1, so if I test negative 2.1, I'm testing here. The top is negative. All right, guys, I lost my train of thought here. I just got interrupted, but coming back, if we plug in negative 2.1, which is to the left, that means that the top stays negative, the bottom stays negative, and the whole thing is positive. So that's the first part of it. And then the second part, you'd have to do from the right. So you could do like negative 1.9. Top stays negative, bottom is positive, so it goes to negative infinity. So one is going up and one is going down. Okay, so this would look something like that, maybe like that. So that makes this one be D and E. For number 15 is getting a lot of questions here. There's a big difference between limit as x goes to 0 of sine x over x. That is 1, okay? It's 1 not because anything cancels out, because when we graphed this, it looked like this. So that's why that is that. Is not the same as what's given here. Limit as x goes to infinity sine x over x. This is a growth rate problem. We are struggling with this question. If you plugged in 1, I'm going to kind of work this out a little bit here, but if you plugged in 1, it's the sine of 1 over 1. If I plug into my calculator the sine of 1, you're going to get, it's 0.84. So this is 0.8 over 1. Let's say I plugged in 100. If I did the sine of 100 over 100, I'm still going to get a decimal on the top. So the sine of 100 is negative 0.5. But it's over 100. So you can see the pattern here. If I did 1,000, so I'm going to infinity with my x. Sine of 1,000 over 1,000, I'm still going to get a decimal. Sine of 1,000 is the sine part of it. I'm just going around in circles here. It's 0.82 over 1,000. You can see this is going towards 0. Okay, so it's a growth rate problem. The sign doesn't grow. It goes up to 1, down to negative 1. But the bottom is growing to infinity. Okay, so we're going to get 0 for that part of it. And then 0 minus 4 is negative 4. That was 15. All right, number 16. Okay, so again, is I'm getting the feeling, but I'm not sure, but I get the feeling by looking at this that this is a vertical asymptote, but I'm not sure, so let's do it. So you're going to get, on the bottom, you get x minus 1, x minus 2. So this is an interesting question. Is the limit as x goes to 1 from the right-hand side, x minus 2, x minus 1, x minus 2. Is there's a hole at 2, which is fine, but they're asking us to find the limit as it goes to 1. I don't care what's happening at 2. That's what you have to understand. At 1, there's still an asymptote. Is there still an asymptote? So I need to figure out at 1, from the right, what is this graph doing? If there is an asymptote that this is approaching, then it's either going to positive or negative infinity. Okay, so I'm going to plug in, so 1.1. So if I plug in 1.1, this is 1 over 1.1, it's going to go to positive infinity. This is a growth rate problem, okay, because remember, it goes square root. So square root, the slowest, then we've got polynomial, so x squared, and then we have exponential, 2 to the x, e to the x. So this versus this is going to go to 0. The bottom is going, the bottom's growing faster. If you wanted to, you could look at exponents, but I don't know that that's going to help you. It's bigger on the bottom. It's just growing bigger on the bottom, okay? All right. Yeah, you could look at it like that, I suppose. Limit as x goes to infinity. Just remember, in rational functions, when it's bigger on the bottom, it goes to 0. Either way. All right, for number 18, is at a quick glance, I'm going to assume we're going to get a vertical asymptote here because there's nothing on the top to cancel. I'm going to go ahead and factor it. Let's see what happens. You got the limit as x goes to negative 1, negative 5, x minus 1. I'm sorry, x plus 1, x plus 1, which means there's a vertical asymptote. Vertical asymptote at x equals minus. All right, so we're going to test around, so x equals negative 1. I need something smaller than negative 1. So this is kind of that weird case because on the bottom here we're going to have, it's negative 5 over x plus 1 squared. So the bottom is always going to be, you don't even have to plug in here. Yes, the top is always going to be negative because there's nothing to plug in here. The bottom is always going to come out positive because it's squared, which tells me it's both sides. No matter what I plug in, it's always going to be negative over positive, which is going to go to negative infinity. So for number 18, this would be, I guess, a special case, if you will, that it's going to go to negative infinity, even though we're going to negative 1 from both directions. All right, for number 19, you want to pick the highest exponent. So I'm going to pull out the highest exponent. Remember, as in pre-calc, when we did this, or in algebra 2, this was a slant asymptote. There was no horizontal asymptote. So as x goes to infinity, so we're going to get negative 5x cubed over x squared. I like to simplify. I take the leading powers, and that's what I'm going to work with. Look, I know it's going to a positive or negative infinity, as it's the opposite of when it's bigger on the bottom. When it's bigger on the bottom, it goes to 0. Bigger on the top, it's growing more rapidly. So I'm going to say limit as x goes to infinity. You can't go wrong doing it like this. I'm going to simplify it. So you get negative 5x. So now, look, I know it's positive or negative infinity. If I plug in here, negative times a positive gives me negative infinity for number 19. All right, for number 20, again, there is a vertical asymptote at x equals 2. There's nothing we can do here. You plug in, you're going to get negative 1 over 0. So I'm going to test it around x equals 2. But again, I feel okay knowing that top is always going to be negative. The bottom is always going to be positive. So it's always going to be negative from both directions. So here and here, which is negative infinity. If you want to plug in values, you can. But if I did 1.9, this is negative, but it comes out positive. 2.1, it's positive, it becomes negative. So they both go to negative infinity. All right, for 21, I don't know what's going on here, so I'm just going to factor limit as x goes to -1, x minus 1 over x minus 2, x plus 1. All right, so nothing cancels out. Okay, that's the takeaway. There's two vertical asymptotes here. There's a vertical asymptote at 2, and there's one at -1. So on a real graph, let me just graph this for a second. And again, I have no idea what this looks like, but I do know that at 2 and -1, I'm going to have a vertical asymptote. But is this, all I care about is what's happening at -1. So as I go, maybe it goes like this. Maybe it goes like this. This has no bearing on the answer to this question. Okay, so I'm testing -1 because it's saying the limit as x goes to -1. That's all we care about. So x equals -1. This is where you really want to make sure you're picking something really close to -1. It's really important that you don't get too far away from it. So if I go smaller than -1, we could do like -1.1, and bigger would be like -0.9. And you definitely want to plug into here because you don't want to calculate values. You don't have time for that. But I just know that if I plug, I don't know, let's plug this one into the top. You're going to get a negative number. You plug it into the bottom. You get 2 negatives, which makes a positive. I believe you get negative infinity for that one. Give me a second to do that again. But if you plug into the top, you're going to get negative. Plug here, you get negative. Plug here, you get negative, so it's positive. I think it's negative infinity. So this goes like that. When I do the other one, let's see what happens. If I plug in negative on top, it stays negative. It stays negative. And a positive, I think. So a negative over negative, which is positive, which makes this DNE. So this one goes like that. Okay, so again, I'm not trying to find values, I'm just trying to find signs. Okay, it's too hard to try to calculate values for this. All right, last couple, 22. It looks like a vertical asymptote. So let me just factor the bottom. You get x plus 3, x plus 3. So we have x minus 1 over x plus 3 squared. My vertical asymptote is at -3. So if we plug in, we're testing at -3. So if I'm to the left or to the right of -3. So this is one, again, you want to be real close around the -3 because it will alter the answer. And it has to do with the top. So don't jump all the way to 0. You don't want to do that. Okay, you want to make sure that you're right around -3. So if I pick something smaller than -3, I would get what? -3.1. So if you did -3.1, the top would become negative, the bottom would be positive. It's negative infinity for that. If I did -2.9, let's see what happens. You're going to get top negative, bottom positive. It's also negative infinity. So I can put negative infinity for that. All right, for this one, I'm going to break it up. You can just do these separately. Limit as x goes to infinity. This is a growth rate problem. I like these. There's no work involved. And then minus the limit as x goes to infinity of 5. So these are nice. This goes to 0. So it's 0 minus 5, which is -5. This just means no matter what you plug in, think of it as the line y equals 5. Okay, it's a horizontal line. Every time you plug in an x value, you get 5. You get 5. You get 5. Okay, so the limit is 5. And then for number 24. All right, last two here. This one looks like an asymptote again. Vertical asymptote, you get x plus 2.
Thank you. There will be no more testing.
x plus 2, so x equals negative 2 is my vertical asymptote. When I plug in negative 2, I get 1 over 0. Means when you get a number over 0, it is a vertical asymptote. So I'm going to test negative 2. So if I want something smaller, so negative 2.1, negative 1.9 should work. So I'm going to plug into here. I like plugging into the factored version because you can see it a little bit easier. But if I plug in negative 2.1, the top is positive. The bottom, both negative, but it becomes positive. So this is positive infinity. If I do negative 1.9, I believe it's positive as well. So it's positive infinity for 24. And then for 25 is this. I would break it up. It can be overwhelming if you try to look at all at the same time. Because when you break it up, this is a piece of cake, I think. I hope at this point, x over x minus 1. As this just goes to 0. Remember, 1 over infinity is 0. This is just a rational function. You look at the powers, they're the same. You take the coefficient. So 0 minus 1, which is negative 1. All right, you guys, hope this video helps. I will be to school pretty early tomorrow, so if you want to swing by around 7:20, that should be fine. Happy to help if you have any questions. See you tomorrow.